to determine the magnitude of the electric field strength between the plates, the easiest thing we can do is V divided by D. So we know that we have V, which is 20 volts, and we have the D, which I was missing before, is 50 centimeters. So we can now say 20 volts divided by, always remember, the standard unit for distance is meters, so we should use 0.50 here. And so that will give us 40 newtons per coulomb, or you could say volts per meter. Either one is absolutely fine. And so that's to two significant figures as well, because of each of the values we've used have been to two significant figures. How would you find the time for the electron to move between the plates? So this is a really nice question because it's combining areas of study, or yeah, different content from different areas of study. What this question is relying on is you to recognize that in the situation we're describing, we have a uniform electric field. Because we have a uniform electric field, that means we have a constant force acting on the charge, and it's moving in a linear direction. So we've got a constant force, and that force is in the direction of motion. So whereas, say, in circular motion, we also have a constant magnitude of force, but the direction is always perpendicular to the direction of motion. Here, the constant force is always in the direction of motion, which means we have linear motion, as in it's going in a straight line. And what that means is we have constant acceleration. So basically we have a constant acceleration problem here. It's just that rather than being a car or whatever else that we would have done in the area of study from book 1, we're just dealing with a very small thing, being an electron. So we can figure out what the acceleration is with the force. So we need to find what that force is. So step 1, find the force on the electron. So I'll do the steps in blue and then the actual working for it here in black. I haven't left myself heaps of room, but we'll make do. So we can find force as QE is probably the easiest way. We could, it's kind of, again, we can manipulate the different equations here into sort of transpose them around to get different ways of finding force. So say in this equation, I hope you can see me pointing to it, the one sort of in the center of the screen at the moment, you can see that if we take the force here and transpose the Q over to this side, we get Q times E. But we could also do QV divided by D, for example, and we know all those things. We basically know everything about this situation for question 3 now. We know E, V, D, and Q, so we can kind of manipulate things in whatever way we like, but the simplest way for us to get the force is just going to be Q times E, because we have those things now. So that is 1.6 times 10 to the negative, sorry, not 11, negative 19, multiplied by the electric field strength, which we calculated was 40. That will give us 6.4 times 10 to the negative 18.